Hello students, today we are going to solve second numerical of crashing. Question is given as A, B, C, D are the activities. Their normal and crash durations and associated cost are given in the table below. For the entire project, the indirect cost is rupees 1000 per day. A and B are starting activities, C follows B, D follows A, and C. D is the finishing activity. Draw CPM network, calculate points for PTC graph and plot the same. Determine the optimum cost and optimum duration for the project. PTC is the project time cost trade-off graph. Now in this table, activity is given, normal duration, normal cost, crash duration and crash cost is given. For activity A, normal duration will be equals to 8 days, normal cost equals to 6000 rupees, crash duration equals to 4 days and crash cost equals to 12,000 rupees. Similarly for B, C and D also given in this table. Now first of all we need to calculate the delta C value, which will be equals to crash cost minus normal cost. So it will be equals to 12,000 minus 6,000, it will be equals to 6,000. For activity B, it will be equals to 14,000 minus 2,000, it will be equals to 12,000. For activity C, it will be equals to 8,000 minus 4,000, it will be equals to 4,000. And for activity D, it will be equals to 4,000. Now delta T value can be determined by subtracting the crash duration from the normal duration. It will be equals to 4, it will be equals to 2, 6 and 2. Now we can find the value of cost slope, which will be equals to delta C upon delta T. Now 6000 upon 4, it will be equals to 1500 rupees. Similarly 12,000 divided by 2, it will be equals to 6000. 4000 divided by 6, it will be equals to 666.7. and 4000 divided by 2, it will be equals to 2000. So we had determined the cost slope of each and every activity. Now we will draw the diagram as per the given condition in the question. Now we need to find the value of TE and TL. For event 1, TE will be equals to 0 always, and we need to calculate the value of TL and slack. Now for event 2, TE and TL as well as slack is also needs to be determined. Here also TE, TL and slack needs to be determined. Now for event 4, TE, TL and slack is also needs to be determined. Now 0 plus 4 equals to 4 here. 4 plus 10, 14 plus 0 plus 8, 8. Now the maximum value will be written here, that is 14. 14 plus 6 equals to 20 for this. Now if TL value is not given for the final end event, then it will be equals to TE, that is 20, and slack will be equals to 0 because it will be the difference of TE and TL. Now we can calculate the TL value for event 3, it will be equals to 14 and slack will be equals to 0. Now we can find the TL value for event 2, it will be equals to 14 minus 10 equals to 4 and slack will be equals to 0. Now for event 1, the TL value will be equals to 0 because 4 minus 4 equals to 0 and slack will be equals to 0. Now we have to find the critical path for this network, that is this, because this is the path joining the events having 0 slack value. Now total duration for this case will be equals to 20 days. Now direct cost will be the sum of all the direct cost, so it will be equals to 6000 plus 2000 plus 4000 plus 4000, and the sum of this will be equals to 16,000. That will be the direct cost. Now we have to find the value of indirect cost. Indirect cost will be equals to the total duration into the indirect cost given in the question, that is 1000 per day. So it will be equals to 20,000. Now we have to find the total cost. It will be the sum of direct cost and indirect cost. So 20,000 plus 16,000, it will be equals to 36,000. That is the total cost as per the original condition given in the question. We have to crash activity C by 6 weeks. Crash activity C by 6 weeks. So for this network diagram, we have to write the normal duration as well as the crash duration. So here for activity A, normal duration will be 4 and crash duration will be equals to 2. Here we had crashed this activity by 6 weeks, so normal duration will be equals to 4. Now here 8 and 4 is written and here 6 and 4 is written. Now that is the network diagram as per the second condition, that is crashing activity C by 6 weeks. So we had find the TE, TL and slack value. Now we have two critical path, that is first path will be like this and the second critical path will be like this. Now the total project duration will be equals to 14 days. Now direct cost can be determined by adding the cost slope in the direct cost of the previous case, that is 16,000 plus 6 into 666.7. On adding these we will have the direct cost equals to 20,000 rupees. Now indirect cost will be equals to 14 into 1000 and it will be equals to 14,000. So total cost will be equals to 20,000, that is direct cost, plus 14,000, that is indirect cost. After adding both this value we will have the total cost equals to 34,000. Now we have to crash activity D by 1 week because it is having the minimum cost slope. So crash activity D by 1 week. Now after crashing of the activity D by 1 week, now we have the network diagram as per the third case, that is crashing activity D by 1 week. So we have calculated the TE, TL and slack and we have the two critical path as 1, 2, 2, 3 and 3, 4 and the next path will be 1, 3 and 3, 4. So project duration will be equals to 13 days. Direct cost will be equals to 20,000 which we had calculated earlier plus 2,000, that is the cost slope for activity D. After adding these two values we will have the direct cost equals to 22,000 rupees. Now indirect cost will be equals to 13 into 1000 which is already given in the question, so it will be equals to 13,000 rupees. So total cost will be equals to direct cost, that is 22,000 plus indirect cost, that is 13,000. After adding these values we will have the total cost equals to 35,000 rupees. So optimum duration equals to 14 days and optimum cost equals to 34,000 rupees. That is all about the second numerical of crashing. Thank you very much, students.